Okay. Simplifying rational expressions. So we'll write out 4a here. We got a whole slew of them here on the side. We got m minus 2 divided by m squared minus 5m plus 6. Okay. The bottom here, if we take a look at it, is very similar to like a quadratic that you may be familiar with, right? And this is written in like what's known as the standard form of a quadratic. It'll probably help if we can put this into a factored form. In fact, it'll be really helpful. If we can put it in factored form, we can also find out some of the restrictions for when we go to graph, or some values that m could never technically be, because what would happen is we'd create a 0 on the bottom. We'll get a little deeper into that. We'll do a little bit of work to start. To start off, our goal here is we're just going to look at this, okay? So I'm going to separate that, and I'm just going to focus on that. I'll write it in, I guess, blue below. So this way, I'm just not writing the denominator every single time, but realize that we are going to go back to this rational expression. So we'll just focus on the denominator at the moment. M squared minus 5m plus 6. Okay. If you remember decomposition, or what's the other one they call it? Decomposition or sum and product, we're going to factor this. So we're looking for two values that equal to a times c. Okay, so this is actually a, c, and a b here in standard form. So we need two values that multiply to whatever a times c is. And in this case, 1 times 6. So they multiply to 6. And those same two values need to add up to whatever our b value is, which happens to be negative 5. If we quickly take a look to negative 5, we can use negative 2 and negative 3. And those also multiply to positive 6. Whoops. Said the word wrote the number I was saying out loud. There we go. When we decompose this, technically we split the middle. But if you're okay with this, do you want me to go through every single step of the factoring? Maybe I will, just as a refresher here.
Okay, sure, yeah.
Yeah? It's up to you. Do you know that it really just ends up being m minus 2, m minus 3?
Yeah.
Okay. So if you know that, you don't need to see the steps. Let's just jump to that. So what we've done is we've now manipulated the denominator. So I'm going to rewrite this, okay? So rewrite this equation. It's originally, we'll put our equal signs here, m minus 2 divided by, okay, we'll move down the page a bit. We'll have m minus 2 and m minus 3. So first off, what we can't have happen is we cannot create a scenario where we have a 0 on the bottom. Any number, I wrote a 1 on top, but really technically any number divided by 0 is going to be undefined. So we can't have the denominator here. We can't set it equal to 0. So again, I'm going to split it off because I'm just going to find out what the restrictions are, and then I'm going to simplify this. So we've split it again. Even though we factored it, I'm going to highlight it. I'm just going to focus on this part again, and I'm going to set it not equal to a value, okay? Because that value creates a 0. We can't have this equal to 0. So instead of an equal sign, we use a not equal sign. In this case, it's two terms. Think of it like two terms multiplied by each other. You could even call it like a times b if you like. And in either scenario, we just can't have a or b equals 0. So in order to figure out what would create that, we split the equation. What would cause one of these brackets to be equal to 0? Well, to solve it, we take the bracket m minus 2 and we say can't equal 0, and m minus 3 can't equal 0. And we isolate for the variable. We move 2 over. M cannot be the value of 2, and m cannot be the value of 3. So those are our two restrictions. So when we finish simplifying this, we'll kind of write this out at the end. We'll say m cannot equal 2 and 3. We put a comma beside it to simplify it, okay? We'll go back to that original expression. Sorry, I've made this a very vertical page. We have m minus 2 as the numerator, and we have m minus 2 and m minus 3. Think of this top like having a set of brackets around it, okay? And in fact, m minus 2 and m minus 2, they create a 1 when you divide the two of them. You could even think of it like this. I'll give you a scenario. What if we said m minus 2 was equal to a? I would say a over a times m minus 3, because we haven't said anything about that one. And then this looks a lot more like something I can simplify. Oh, a divided by a, that just kind of cancels out or creates a 1, right? There'll be a 1 on top.
Yeah.
So these cancel out, and we're left with 1 over m minus 3 with the restriction of m cannot be the value of 2 or 3 in this case.
Why would it be 1 on top? Couldn't you just write m minus 3 as the answer?
So we don't technically cancel out. So this is a common misconception. When you cancel stuff out, there's invisible numbers. Technically, there's a coefficient of 1 here. Okay? In fact, I can put a coefficient of 1 here also. And when this disappears, that 1 stays. If the bottom 1 stays, that's okay too, because 1 times m times minus 3 is just m minus 3. But on the top, if I cancel it out and created a 0, the entire thing would be equal to 0. So when we do this division, when you divide a number by a number, you actually create the number 1. Think of the idea of 5 divided by 5. If I have 5 divided by 5, that actually equals 1. And I can write 1 as a fraction. I can say, well, that's also equal to 1 over 1. Okay? So that 1 always has to stay on the top there. Okay? So that's a really important piece to this.